Hello everyone. Today I am starting the topic Hessian matrix. What is Hessian matrix? The definition of Hessian matrix is let f of x comma y be the function of two independent variables x and y. The function has two independent variables x and y. Then the Hessian matrix of two independent variables of the function is given by hf equals to dou square f by dou x square, dou square f by dou x dou y, dou square f by dou y dou x, dou square f by dou y square. So the first row, first element is we are differentiating f with respect to x two times. Next, first row, second element is differentiating f with respect to x and y. And differentiating next, second row, first element is differentiating f with respect to y and x. So you can easily remember like this. Suppose two independent variables x, y, x, y. So x into x, x square. So that means differentiating f with respect to x and x. Differentiating f with respect to x and y. Differentiating f with respect to y and x. Differentiating f with respect to y and y. We get the Hessian matrix. In the same way, Hessian matrix can be written for the function which has three variables. So now see what is the Hessian matrix for function of three variables is dou square f by c. Suppose x, y, z. Don't write x, y, z when you are writing the definition in the examination. Just I tell the shortcut to remember the matrix of Hessian matrix for three variables x, x, x square. So differentiate f with respect to x and x. Differentiating here x and y. So now multiplying x and y, differentiating f with respect to x and with respect to y. Now this is z. Differentiating f with respect to x and with respect to z. Differentiating f with respect to y and x. Differentiating f with respect to y and y. Differentiating f with respect to y and z. Differentiating f with respect now z, third row, z and x. Differentiating f with respect to z and with respect to x. Differentiating f with respect to z and y. Differentiating f with respect to z and z. So dou square f by dou z square we get. Now coming to the topic, maximum and minimum of a function of two variables by Hessian matrix. So the procedure we have to follow some steps to find the maximum and minimum of the function by Hessian matrix. First, given function, that function here, that is the function of two variables. Now differentiate f with respect to x and with respect to y in step 1. Now step 2, take the derivatives equals to 0. That means dou f by dou x equals to 0 and dou f by dou y equals to 0. Then we get two equations. Now solve the above two equations, we get some points. Some order pairs we get. Because since it has two independent variables, so we get order pairs. So a1, b1, a2, b2, we may get one order pair, we may get two, we may get three. So we get some order pairs. More than one only, 2, 3, like that we get order pairs, depends upon the equations. Now in the step 3, these points, these order pairs, whatever we are getting by solving the two equations, that points is nothing but stationary points. Now step 3, again find. Now L, M, N are introduced. What is L? L is nothing but dou square f by dou x square. What is M? Dou square f by dou x dou y. What is N? Dou square f by dou y square. Okay, so now L means dou square f by dou x square, M dou square f by dou x dou y, N dou square f by dou y square. Now the Hessian matrix. The Hessian matrix is dou square. Hessian matrix for two variables is, this is the matrix. Now see what is L. L is nothing but in the previous step L is nothing but dou square by dou x square. So just we are taking, instead of writing dou square f by dou x square, just we put L. Dou square f by dou x dou y means M. Instead of writing this and all, we just denoting with LMN. Now modulus of Hessian matrix HF equals to modulus of LMMN. Okay, now after finding HF, already we find L value, M value, N value. Now substitute LMN value in this determinant, we get some value. Now we have to, in the step 2, by solving the two equations we get stationary points, right? So that stationary points we have to substitute in this Hessian matrix one by one. So first take the first order pair A1 B1 and now substitute these A1 B1 in modulus of HF, modulus of Hessian matrix. If that after substitute A1 B1 in Hessian matrix, if that value is negative or equals to 0, then that point is called saddle point. That means at this point the function has no maximum and no minimum. When the function has no maximum and no minimum, if the point, if when you substitute the stationary point in the Hessian matrix, if that value is either negative or equals to 0, then that function has no maximum and no minimum at this point. That point is nothing but saddle point. Saddle point definitions you may get. What is saddle point? Saddle point means at which points the function has no maximum and no minimum, that point is nothing but saddle point. Now second, suppose if it is greater than 0, if we substitute stationary point in the Hessian matrix, modulus of determinant of HF, if that value is greater than 0, okay, immediately you substitute that point in L. L means dou square F by dou x square. You substitute. If that value is also greater than 0, okay, that means if this determinant is greater than 0, immediately substitute that point in L. If that value is also greater than, then the point is minimum point. If it is positive, then the point is minimum. Now, by substituting that point in the function, we get the minimum value of the function. Okay, now next case 3. If suppose this is greater than 0 and immediately when you find L value at the point A1 comma B1, if that value, L value is negative, then the point is maximum. If L value is positive, then the point is minimum. If L value is negative, then it has a maximum. So immediately substitute that point in the function that is the maximum value of the function. This is the procedure to find the maximum and minimum value. Now coming to the problem. See, this is the problem. Find the maximum or minimum of x square y plus xy square minus axy. Okay, so this is function of two variables x and y. Now given that f of x comma y equals to x square y plus xy square minus axy. Dou f by dou x equals to, now step 1, what we have to calculate? Derivative f with respect to x. Now dou f by dou y equals to, what is dou f by dou y? X square plus 2xy minus ax. Now step 2, what is step 2? Take the derivatives equals to 0. Take dou f by dou x equals to 0 and dou f by dou y equals to 0. So that is 2xy plus y square minus ay equals to 0. Take this is equation number 1. Now next x square plus 2xy minus ax equals to 0. Take this is equation number 2. Now we have to solve these two equations. Okay, when by adding these two equations or by multiplying, by division or by subtracting. So any one of the logic, apply any one of the logic, then you can find the order pairs. That means x comma y values. So now from equation 2, I am taking that or either by adding or by subtracting or by substituting. Take two equations, substitute second equation in one equation or one equation in second equation. Any one of the logic you can apply. So from equation 2, I can find 2xy equals to ax minus x square. Here it has 2xy, here it has 2xy. So from the equation 2, I am finding 2xy value. Or if you want, you can take 2xy from the equation 1. 2xy equals to ay minus y square you may get. Substitute that value in the equation 2. But here I am taking equation number 2. From equation 2, I get 2xy equals to ax minus x square. Now substitute this value in 1. From 1, what is 2xy? Ax minus x square plus y square See, from 1, I am substituting this value in equation number 1. So 2xy. 2xy means ax minus x square plus y square minus ay equals to 0. This implies y square minus x square plus ax minus ay equals to 0. Y square minus x square I can write as y minus x into y plus x plus ax minus ay. From this you can take a value. Then we get a into x minus y equals to 0. See, here x minus y is there. From this also we can take x minus y. From both the terms, if you take x minus y or y minus x, suppose I am taking y minus x. Okay, if I take y minus x from both the terms, I get y plus x. Here x minus y is there. If you take minus a, we get this equals to 0. Okay, a into b equals to 0, that implies a equals to 0 or b equals to 0 or a equals to 0 and b equals to 0. So that implies y minus x equals to 0 and y plus x minus a equals to 0. In the next page, what we get here? Y minus x equals to 0 and y plus x minus a equals to 0. That implies y equals to x and x plus y equals to a. I am taking a outside, x plus y equals to a. Now by substituting, so finally I get this one, y equals to x and x plus y equals to a. If y equals to x, now substitute this value in either equation 1 or equation 2. I am substituting in equation 2. Okay, what is equation 2? What is equation 2? X square plus 2xy minus ax equals to 0. This is equation 2. That is nothing but dou f by dou y equals to 0. Now I am substituting y equals to x in this equation. That implies y equals to x. So now substitute x square plus 2x minus ax equals to 0. That implies x square plus 2x square minus ax equals to 0. That implies 3x square minus ax equals to 0. Take x common, we get 3x minus a equals to 0. That implies x equals to 0 and x equals to a by 3. X equals to 0 and x equals to a by 3. Now, see, if you take y equals to x, I get x equals to 0 and x equals to a by 3. Two other values I am getting. Actually, y is in terms of x. Y is not exact value. Y is in terms of x. Now, I get x values. By substituting x values, I get y value. If x equals to 0, that implies since y equals to x comma to y equals to 0. So, therefore, I get order pair x comma y is x comma y equals to x value 0, y value 0. One order pair I get. Now, if x equals to a by 3, that implies y value is also a by 3. Therefore, another order pair x comma y equals to, what is that? A by 3 comma a by 3. Okay. So, these two order pairs get when I take y equals to x. Another value I have to take x plus y equals to y. So, if I take x plus y equals to a, x plus y equals to a. So that implies from this either you can take y or you can take x. X equals to a minus y. Okay, now substitute this in equation number 2. Equation 2 substitute. What is equation 2? X square. X square means a minus y whole square plus 2 into a minus y into y minus a into a minus y equals to 0. Each and every term a minus y is there. Don't expand. Observe, each and every term has a minus y. Now take a minus y common. We get a minus y plus 2y minus a equals to 0. So this implies a minus y into a minus y plus 2y. If you multiply, you get like this, 0. Minus a plus a get cancelled. So a minus y into minus y plus 2y is y equals to 0. So that implies a minus y equals to 0 and y equals to 0. Okay. So a minus y equals to 0 and y equals to 0. these two values, that implies y equals to a and y equals to 0. These two values came from when you take x equals to a minus y, right? Now y equals to a. X is in terms of y, if you take, then you get y equals to a and y equals to 0. So if y equals to a, then substitute that value here. X equals to a minus a, 0. So that implies, therefore, f of x comma, order pair x comma y, x value we get, y value get, x comma y equals to 0 comma a. Now if y equals to 0, then x equals to a minus 0, that equals to a. So therefore order pair x comma y is a comma 0. So finally, previous when you take y equals to x, if you take y equals to x, we get two order pairs. If you take x plus y equals to a, we get another two more order pairs. So total how many order pairs we get? Therefore a 0 comma 0, take like this, b a by 3 comma a by 3, c 0 comma a, and d a comma 0. These order pairs I get when we solve the two equations. Now these points are nothing but stationary points, stationary points. Now in step 3 already completed, I think so. Now step 3, L we have to find. L equals to, L is nothing but what? Dou square f by dou x square. That equals to dou by dou x of dou f by dou x. That equals to dou by dou x of, what is dou f by dou x? Turn the page, you will get what is dou f by dou x? 2xy plus y square minus ay. Now find the derivative this with respect to x. 2y. So L value equals, that implies L equals to 2y. Keep in box. Now next m equals to dou square f by dou x dou y, or dou by dou x, anything you can calculate. Dou by dou x of dou f by dou y. So that equals to dou by dou x of, what is dou f by dou y? X square plus 2xy minus ax equals to, minus ax, no, don't take equals to 0. This equals to 2x plus 2y minus a. So this is m value. Therefore m equals to 2x plus 2y minus a. M value is this one. Now next n is nothing but dou square f by dou y square. That equals to dou by dou y of dou f by dou y. So this equals to dou by dou y of dou f by dou y means what? Dou f by dou y means the same, x square plus 2xy minus ax. This equals to, with respect to y, this is 2x. That implies n equals to 2x. So now L value 2y, m value and n value. Now find Hessian matrix, HF. Since what is HF? HF equals to mod HF equals to modulus of dou square f by dou x square, dou square f by dou x dou y, dou square f by dou y dou x, dou square f by dou y square. So this equals to modulus of L, M, M, N. Right? So this equals to, now substitute what is L value. What is L value here? L is nothing but 2y. M value 2x plus 2y minus a. And m value, again m value 2x plus 2y minus a. And again n value 2x. So this equals to, now find the determinant. Find the determinant of this one, we get, find the determinant of this one, we get mod HF equals to 4 minus 4xy minus 4x square minus 4y square minus a square plus 4ay plus 4ax. Keep this in box because we have to verify each and every stationary point in this HF. in this determinant of Hessian matrix. So we have to keep like this. Now step 4. Step 4, each and every stationary point we have to take and substitute it. So now first point, take first ordinary order pair A0 comma 0. Now HF at, so this is case 1. Case 1. Step 4, case 1. HF at A0 comma 0. So x value is 0, y value is 0. Now substitute here. So minus 4 into 0 into 0, 0, 0, minus a square plus 0 plus 0. We get final value is minus a square. Minus a square. This is negative. So it is less than 0. So mod HF at order pair 0 comma 0, the value is less than 0. Less than 0 means then the function has no maximum and no minimum at this point. So at which point the function has no maximum and no minimum, that point is nothing but saddle point. So therefore the function has no maximum and no minimum, no max and no minimum at 0 at a0 comma 0. So therefore a0 comma 0 is called saddle point. Is called saddle point. Sometimes the question comes like this: find the saddle points, find the stationary points. Only 2 marks question. For 2 marks question they can give. So is called saddle point. Now case 2. No need to find next L value, no need to substitute this value in L, and no need to find the F, because we conclude that at this point the function has no maximum and no minimum. Now case 2, take case 2. So that is, take b value a by 3 comma a by 3. So now HF at b a by 3 comma a by 3. Now take x value is a by 3 and y value is a by 3 and substitute here. Minus 4 a square by 9. Substitute in this. In this HF we have to substitute every point. Minus a square by 9. Minus 4 a square by 9. Minus 4 a square by 9. Because y value is a by 3. A by 3 whole square means a square by 9. Minus a square plus 4 a square by 3 plus 4 a square by 3. Since here it is 4ay, y value is a by 3. So a into a square by 3, a square by 3. So if we simplify, we get answer a square by 3, which is, now final answer is a plus a square by 3. So it is greater than 0. So I get HF at this point is greater than 0. Therefore mod HF at a by 3 comma a by 3 is greater than 0. So then immediately find L value at this a by 3 comma a by 3. What is L value here in this problem? 2y. So 2y at a by 3 comma a by 3. So substitute y value is a by 3. So we get 2a by 3. 2a by 3 is positive value. Then it is greater than 0. So HF is greater than 0 and L is also greater than 0. L value, if L value is greater than 0, L value is positive, then the point is minimum. Then a by 3 comma a by 3 is minimum point. Is minimum point. Okay. Immediately we find F at b a by 3 comma a by 3. This equals to, what is F? X square y plus xy square minus axy. So this equals to a square by 9 into a by 3 plus a by 3 into a square by 9 minus a into a by 3 into a by 3. This equals to a cube by 27 plus a cube by 27 minus a cube by 9. So if you take LCM and simplify, we get answer minus a cube by 27. So at this point, this point is minimum. So when you substitute the value in the function, that value whatever we are getting, that is the minimum value of the function. So minimum value of the function is minus a cube by 27. Now the problem is not completed, only second point is completed. Now we have to check the next point. Case 3. Case 3 is take C point. Take C, what is C? A comma 0. A comma 0. Now find HF at C A comma 0. So that's equals to, if you substitute, every value is getting 0, 0 minus 4a square minus 0 minus a square plus 0 plus 4a square we get. Minus 4a square plus 4a square we get cancel, minus a square. Minus a square, it is negative, so it is less than 0. So mod HF at the point is negative, then the function has no maximum and no minimum. Then the function has no maximum and no minimum. No max and no minimum. Okay. Now that means C A comma 0 is saddle point. Saddle point. So now next case 4. Next fourth order pair you have to check. So case 4. Case 4. That is D 0 comma A. Now mod HF at D 0 comma A equals to 0 minus 0 minus 4a square minus a square plus 4a square plus 0. So this one get cancelled. Again we get minus a square which is less than 0. Again it is negative value. So therefore the point D of 0 comma A is saddle point. That means at this point the function has no maximum and no minimum. Function has no maximum and no minimum. No maximum and no minimum. So all the stationary points we completed. Now conclusion. Write the conclusion. At which point the function has maximum or minimum value, you just write. So only at B point. B A by 3 comma A by 3. Okay. That implies F at A by 3 comma A by 3 value is, what is the value we get? Minus A cube by 27 minimum. So if you want to, if in the question if they asked what are the saddle points, you can mention 0 comma 0 is a saddle point, A comma 0 is a saddle point, and 0 comma A is saddle point. What are the stationary points? So four points are stationary points, saddle points. So what is extreme point? Extreme point ante at which point the function has either maximum or minimum, that is extreme point. So A comma 3, you just write, mention if they asked. One problem, if you write, then you can understand. Stationary points. Conclusion step. If they mention in the question, then you can write. Otherwise, no need. Stationary point. Stationary points. What are the stationary points? 0 comma 0. B A by 3 comma A by 3. C 0 comma A. D C A comma 0. D 0 comma A. These are the stationary points. What are the saddle points? Saddle points. Saddle points means at the function has no maximum and no minimum at points, that points. So A 0 comma 0 and C A comma 0 and D 0 comma A. These are the saddle point. What is extreme value? Extreme value or extreme point. Extreme point means at which point the function has either maximum or minimum. So here I get the function has minimum value at this point. So B A by 3 comma A by 3. So this is the extreme point. The extreme value is this one. Okay. So I hope everyone understood. So if you like this video, please subscribe and give like. Next problems will be continued in the next video. Thank you.